This video will cover the Geometry Common Core exam from June 2015, questions 12 through 16. Question 12 says, in scalene triangle ABC, shown in the diagram below, the measure of angle C is equal to 90 degrees. So that's already marked here as a 90-degree angle, right angle. Which equation is always true? And we see all of these choices say sine of A equals sine of B, cosine of A equals cosine of B. So it's all of these equations with sine and cosine. These are called cofunctions. And the cofunction definition says that the sine of theta, some angle, should be equal to the cosine of 90 minus theta. So for example, sine of 60 should be equal to the cosine of 90 minus 60. 90 minus 60 reduces to 30. So now I have sine of 60 equals cosine of 30. So again, it's always a relationship between sine and cosine, never the same trig function equal to itself. So that immediately eliminates 1 and 2. Now I have cosine of A equals sine of C. Well, C is the 90-degree angle, and not only do we have 90 minus theta, I can't talk about the 90-degree angle itself in this equation, because I know that angle A is larger than 0. So that leaves me with choice 4. And again, if we choose to talk about 60 and 30, I have 60 here and 30 here. If we talk about sine of angle A, sine, remember, is opposite over hypotenuse. Opposite of A is segment CB. Over the hypotenuse, which is always across from the right angle, which is AB. But when we think about cosine of B, here's B. Cosine means to use adjacent over hypotenuse. Adjacent to B is again CB. And the hypotenuse is still AB. So whether I'm talking about the sine of A or the cosine of B, I'm still using the same exact side lengths, which gives me again choice 4. Question 13 says quadrilateral ABCD has diagonals AC and BD. So if we sketch this, we have diagonals A, C, and BD. So here's A, B, C, D. AC is a diagonal and BD is a diagonal. And we're asked to figure out which information is not sufficient to prove that ABCD is a parallelogram. So there's several different ways to prove, and we're going to list them, and then we'll figure out which one of these ways will not be helpful. Ways to prove parallelogram. So the first way is using the properties, the fact that the diagonals bisect each other. Diagonals bisect. So if we look at choice 1, that is a way to prove prove that ABCD is a parallelogram. Our next property is the fact that both pairs of opposite sides are congruent. So meaning BC is congruent to AD and AB is congruent to CD. So that's choice 2. Again, we're trying to find a not here. The next property we can think about is that both pairs of opposite sides are parallel. So again, BC is parallel to AD, and AB is parallel to CD. Now, it doesn't look like in either choice 3 or 4 that we're talking about both pairs of sides being parallel. Both pairs of opposite sides are parallel. So we have another property. Both pairs of opposite angles are congruent. And again, in choice 3 and 4, it doesn't look like we're talking about angles here. So I'm going to move on to another way to prove. One pair of opposite sides are congruent and parallel. So one pair of opposite sides are congruent and parallel. If I look at choice 3, it's talking about AB is congruent to CD. True. And AB is parallel to CD. Also true. So this means that choice 4 should be our answer. AB is congruent to CD. True. But then they're talking about BC is parallel to AD. And although both of these are true statements in and of themselves, it's not a way to prove, because we start by talking about one set of sides being congruent and then a different set of sides being parallel. So choice 4 is our answer. Number 14 says the equation of a circle is x squared plus y squared plus 6y equals 7. What are the coordinates of the center and the length of the radius of the circle? This equation is written in general form. The standard form for the equation of a circle will allow us to find the center and the radius. And it looks like this. X minus h, quantity squared, plus y minus k, quantity squared, equals r squared, where h comma k is the center and r is the radius. So we need to take our equation x squared plus y squared plus 6y equals 7 and move it into this form, which requires us to complete the square. So here I'm going to work with both the x and the y terms separately. I notice that all I have is an x squared. There's no b term to this, no linear term to this x. So I'm going to leave the x squared off to the side by itself. Now I'm going to move into the y terms. So now I have plus y squared plus 6y, and I'm going to put a plus blank. Still equal to 7, but because I'm adding a plus blank on the left, I have to do the same thing on the right. Whatever you do to one side, you need to do to the other. In order to complete this square, I need to take the b value, the linear value, and divide it by 2, and then square it. So again, I took the b value, divided by 2, and squared. 6 divided by 2 is 3, and then 3 squared is 9. So 9 is the value that I'm adding to both sides. So when I rewrite this, I have x squared plus, now I need to factor this whole quadratic here, y squared plus 6y plus 9. If we think about factoring, we have two sets of parentheses with y in the first spot of both. Because I'm adding to a positive and multiplying to a positive, both signs will be positive. And if I think about my factors of 9, I have 1 times 9 and 3 times 3. And I need one of those pairs of factors to add to 6. 1 times 9, of course, gives me 9, but 1 and 9 will never help me add to 6. So I'm going to choose 3 and 3, which is perfect because I need to complete the square. I needed to make perfect squares here. A quick way to determine what value goes here inside your parenthesis is to take the b value, the 6, and just simply divide it by 2, keeping the sign the same. On the right side, I now have 7 plus 9, which is a sum of 16. So I'm going to rewrite one more time. X squared plus, when I take something and multiply it by itself, that's the same as squaring. So I have really the quantity y plus 3 squared equals 16. So now again, based on the equation in standard form that we talked about up here at the top, and the equation that I found here at the bottom, I now can find the center and the radius based on the equation that we wrote. Because there's nothing attached to the x, that means the center value for x is 0. Because I have a positive 3 inside the parentheses, outside of the parentheses I have negative 3. And because r squared is 16, when I square root both sides, I find out that the radius is 4. So 0, -3, and a radius of 4 gives us choice 2. And again, our answers for this page, we have number 12 is choice 4, number 13 is choice 4, and number 14 is choice 2. Number 15, triangles ABC and DEF are drawn below. If AB is 9 and BC is 15, DE is 6, and EF is 10. And the measure of angle B is equal to the measure of angle E, or congruent. They're congruent here, it says, which means that their measures are equal. Which statement is true? So it says that A, B, C, and D, E, F are drawn. And so that means that A is going to map on to D, and B is going to map on to E, and C should map on to F. So I want to make sure that when I do anything with this problem that I'm matching up the corresponding parts. So the first statement says angle CAB, really again here we're talking about the middle letter A, is congruent to angle DEF, where we're talking about E. We did not mark angle A congruent to angle E, but we did mark angle B congruent to E. So this is not a true statement. Number 2 says AB over CB is equal to FE over DE. Because they gave us values, we can actually plug these values in for the expression and cross multiply to solve. See if the left side is equal to the right side. So AB is 9 over CB, which is 15. Equal sign with a question mark because we're not sure if this is going to be true. FE is 10 over DE is 6. So we can again cross multiply to solve. 9 times 6 is 54. And 10 times 15 is 150. So this means that this is not true. So 2 is not our choice. Number 3 says that triangle ABC is similar to triangle DEF. Now we can prove triangles similar in 3 different ways. Prove triangles similar by, we have 3 options, kind of similar to what we can do with triangle congruence, but these are just similar, meaning same shape, different sizes. So we can prove them similar by AA similarity, meaning that we have 2 congruent pairs of angles. We can also prove them similar by SSS similarity, meaning that we have 3 pairs of corresponding sides in proportion, meaning fraction equals fraction equals fraction because there's 3 pairs. Or we can also talk about side angle side similarity, where we have 2 pairs of corresponding sides in proportion and 1 pair of congruent angles. And it's the included angle, meaning the one in between the sides in proportion. So if I set up a proportion with those sides, I would have 9 over its corresponding side. Now, A has a circle going to a square. D is circle going to square of E, so 9 over 6 should be equal to 15 over 10. When we cross multiply here, we end up with 9 times 10 is 90, and 6 times 15 is also 90. So I have 90 equals 90, which means that this proportion is true, which means I have 2 pairs of corresponding sides in proportion. But then don't forget about angle B is congruent to angle E, which tells us that, again, we've got a pair of angles that are included between those sides in proportion that are congruent. So I believe our choice is 3, but let's check out 4. 4 says AB over DE is equal to FE over CB. So that's 9 over DE is 6, should be equal to FE 10 over CB 15. When we cross multiply this one, we have 6 times 10 is 60, 9 times 15 is 135. These are not equal, so 4 is not our choice, which again brings us back to choice 3 for number 15. Number 16 says if triangle ABC is dilated by a scale factor of 3, which statement is true of the image of triangle A prime, B prime, C prime? Now these choices get a little tricky to read and understand, but I want to draw some triangles here. Ooh, this was supposed to be a right triangle, but let's just say that I'm a better drawer than I actually am. So I labeled my angles as A, B, and C, because that's the original triangle, and I'm just going to label with sides of 3, 4, and 5. Anytime you want to talk about triangles being dilated, 3, 4, 5 is a great triangle to start with. Now it says that it's dilated by a scale factor of 3, which means it gets larger. And I'm going to again label the angles, A prime, B prime, C prime. If I start with a right triangle, I should end up with a right triangle, even if I'm dilating. Because I'm dilating by a scale factor of 3, that means to multiply the side lengths by 3. 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. So now I can read through each of these problems, or each of these choices, to figure out what is true. Choice 1 says that 3 times A prime, B prime, so 3 times 12 should be equal to AB. 3 times 12 is 36, which is definitely not equal to 4. So 1 is not my choice. Number 2 says B prime, C prime, okay, so that looks like we're looking at 15 this time, is equal to 3 times BC. Well, BC is 5. 3 times 5 is 15, and we said that B prime, C prime is 15. So it looks like 2 should be our choice. But let's look at the other options. Measure of angle A prime, that's our 90-degree angle, is equal to 3 times the measure of angle A. Well, A was also 90. So 3 times 90 is not equal to 90. So 3 is not our choice. Number 4 says 3 times the measure of angle C prime. Now we didn't give C prime a number, but sure, we absolutely could. I don't know, 40 degrees. So 3 times 40 degrees should be equal to whatever C is. Now if the 90-degree angle stayed the same, then our other angles, C and C prime, or B and B prime, should also stay the same. So this is not true. When you dilate, the side lengths change. Side lengths change. But the angles stay the same. So that again brings us back to choice 2. Our answers for this page, number 15 is 3, and number 16 is 2.